All right, hopefully you can hear me okay. I've got some data collected. This are grades from a class of mine. We have the exam 1 scores, exam 2 scores, exam 3 scores, and then the final exam. And the question that I'm interested in is there any correlation between one of these exam scores and the final exam? So let's do that in Excel. I've typed everything up here. This column is going to be the correlation coefficient for exam 1, and then for exam 2, and then for exam 3. So to find the correlation coefficient between two variables in Excel is pretty straightforward. You just type equals, and then you type in correl. That's the function. You can double click on it, and then you just highlight the first array. The first array typically is your x variable, so to speak, and then the second array is your response variable, your y variable. Go ahead and close out the parenthesis and then hit enter. And oops, that was supposed to be for exam 1. I did exam 2. That's fine. For exam 1, we'll do the same thing. We'll do correlation, and then I'm going to highlight exam 1 columns, comma, and then the final exam, parenthesis to close it out. And there's the correlation coefficient for the first exam and the final exam. And then finally, I can click correlation, and I can do the third exam and the final exam. And so these three correlation coefficients, while I haven't graphed anything yet, they're really nice because I can already get a real strong sense that the second exam is strongly correlated to the final exam. Really anything that's getting in the 0.6, 0.7 range is already pretty good. But when you get up to like 0.8, this would be considered a pretty strong correlation here. So let's visualize this. You can go over here to insert. It's easiest. I want to look at the relationship between exam 2 and the final exam. So I'm going to highlight both of those. Then I go over here to insert and all the way over to charts. And then you can see this scatter plot right here. I want to do just a regular scatter plot. And the scatter plot is being drawn. You can label the axis, but the way I did it by selecting this exam 2 first, then that's the x-axis and the y-axis is the final exam. And you can definitely just at a glance see, oh yeah, there's definitely a linear relationship here. I like to look at the line of best fit just to visualize it, and so I can actually click on trend line. I just went to the little plus chart elements, then I clicked on trend line, and you can change it. I'm assuming linear. When you're working with other situations, there's a lot of things you might study. You can do exponential or quadratic or all kinds of things. We want to do linear. We're doing linear regression. And so that's it. You can see it. Now, I know what the line looks like. I know what the correlation coefficient is, meaning it's strong. I'd like to actually write down the equation of the line. And so I need the slope of this line, and I need its y-intercept. And so the slope m, let's just make a label cell here, m equals. To find the slope, you just click equals, and then you can type in slope, slope, and then you want to highlight. Notice how it says known y's and then known x's. You actually do the output, the y's first for the slope, rise over run, so rise, and then you do the x variables, and then you close out with the parenthesis, hit enter, and I now know the slope of this line is 0.8, and then if I want to find the y-intercept b, I just click in my formula box, I click to type, and I'll type in intercept, and I'll select that, and the same thing, y's first, then the x's. So I do the y's, then I do the x's, and I'll run that, and I get the slope. And so the point is, you've got the line. You know that in general, the equation of a line is y equals mx plus b. I'll just type that here. So our line is actually y equals 0.8195 times x plus 15.60. So if you were asked to write down the actual line, then that's what you would write down. You can actually use this to compute to predict final exam scores. So for example, if you look, I don't think there's a single 75 score on exam 2, but suppose you want to know, if I get a 75 on exam 2, what will my grade likely be on the final? And so you can actually use this formula to predict that. Let's do it. So if you wanted to use a 75 on exam 2, you would say, okay, this cell we're going to say equals, we're going to take the slope m times the score of 75, that's my x, plus the y-intercept b. I'm doing mx plus b, hit enter, and you can now predict a 77.07 on the final exam based on a 75 on the second exam. So that's how you do it. Let me make one more short video. I just want to show you how just because things are correlated doesn't mean that the relationship is necessarily causal. There's a common saying that correlation does not imply causation. And so just a brief video on that, and then you are good to go on the homework.